For this final lab, I chose to implement the wave function collapse algorithm. This algorithm is a method of procedural generation. To understand how this algorithm works, here's a quick example. Imagine we have a row of boxes. Each box can contain one of three letters, A, B, or C. When we first construct these boxes, we have no idea what letter is inside what box. These letters also have specific rules. A can only be next to B can only be next to A and C can only be next to B. Furthermore, any letter can also be next to itself. So say we open one of the boxes and it turns out that it's A. Then we know that the box next to it must only be A or B, per the rules. More importantly, we also know that the box next to it cannot be C. The box then chooses a state to pick at random and continues on to the next box until all boxes in the row have successfully collapsed. This is essentially what I've implemented within Unity, albeit with much more rules and on a variable grid. The rules I have used are in order to simulate something that would resemble a world map. From left to right is the deep ocean tile, the water tile, sand, land, grass, and finally the forest tile. The rules again are about what tile can be next to what other tile. An important note is that directionality is not a concern, and the rules are simply a matter of proximity. With the algorithm in place, here are some generations of 30 by 30 grids. While that's playing, I'll explain a little bit more of what's happening. Each cell in this grid has a heuristic called entropy that guides the algorithm. Entropy is essentially the amount of possible states that the cell could collapse to. When a cell is at a stable state and fully collapsed, its entropy is 1, and on the other hand, when a cell is first initialized, its entropy is 7, which is the max for this implementation. The algorithm follows and looks for cells with the least amount of entropy and then subsequently collapses them. Getting started on this project was definitely something to think through, since I grasped the concept at a high level, but I didn't look at any tutorial code or sample code on how to implement this. So everything was thought from scratch. This led to ultimately very slow performance code. In fact, my previous implementation was rather slow in doing huge amounts of iterations per generation. Since then, this past week was spent greatly reducing the amount of executions being done, increasing the performance significantly. Here's a quick comparison of 20 by 20 grids. As you can see, the new code on the right is doing multiple full executions in the time that the old code takes to do one. So that's it for now. A link to my code will be in the description, and thanks for watching.